All motion is relative. This means that constant velocity, or motion where velocity is constant, cannot be detected unless we have some frame of reference to compare it to. This idea is called or known as the principle of relativity, and it holds true for any frame of reference that is not accelerating. So all motion is relative to some other motion. You can't determine the velocity of an inertial reference frame without referring to other frames of reference. So for the velocity of a car, when you're in it, you can't, if it's going at constant velocity, you can't tell it's moving unless you look out the window and look at a frame of reference outside that of inside the car. The law of physics have to be the same for all reference frames. There's no absolute rest frame. All inertial frames of reference are equally valid. And the only quantity which is independent of the motion of the reference frames is the speed of light. And the speed of light is an absolute constant. And if the speed of light is constant, this has the consequence that other things must be changing, such as time, distance, and mass must become relative. They must be changing. For example, inside a car, if you're in the car and you drop a coin, it appears to fall straight to the ground. However, your car might be moving. So by the time the coin gets halfway, the car is here, and the car is here by the time the coin hits the ground. So this is where the coins drop from, next here, and it's here. A person that's outside this frame of reference in the car, and we're assuming velocity is constant, will see the coin follow the red path. Now if the speed of light is constant, what is changing here? This path here takes the same amount of time as this path here. If they both take the same time but one travels further, this one here, time must be slower to enable this coin to travel the longer path. In that time. Okay, time to travel this path, time to travel this path. The longer path, time must be longer. Something else that we can't really assume is constant anymore is length and time. The only thing that we can assume is constant is the speed of light. So, if we think about that, the meter used to be a platinum rod held in France in the Pasteur Institute. And other meters were taken from that platinum rod of the meter. If that meter is no longer considered constant, in other words, it can change depending on the relative movement between it and an observer, then we need to assume the meter has to be measured in terms of the speed of light. So the meter is now considered a distance over which light travels in a certain number of vibrations of an atom, of a nucleus. We can't propose that the meter is a fixed length anymore. So there are widespread consequences of this action, of this idea. This also led to the idea of the space-time continuum, that any event has 4 dimensions, 3 in space, x, y, z, and a 4th, time, in order to define its position in its reference frame. Also, 2 events that are seen to be simultaneous can be seen to be not simultaneous in a different frame of reference. So things can change dramatically. There are some far-reaching effects of Einstein's theory of relativity.